Hello, this is 2021 Maths. So question 1, the 10 multiple choice questions, starting with A. A regular dodecagon is a 12-sided polygon, all sides the same length, all internal angles equal. If I construct a regular dodecagon by connecting 12 equally spaced points on a circle of radius 1, then the area of that polygon is what? Okay, so we've got they've set up a circle, 12 points on the circle, each one coming back to the center and then turning those into sides. So we've got 12 triangles then like this. So each one of these angles must be 30 degrees because 12 30s are 360. And they're all, what did they say, radius 1, so they're all side 1. So we're going to have 12 lots of half AB sine C. So 12 times a half times 1 times sine 30 degrees, so another half. So that's 3, which is E. Question B. The positive number A satisfies that integral if A is equal to what? Well, let's do the integral then. So that's going to be 2/3 of x to the power of 3 over 2 plus 1/3 of x cubed. Between a and 0, it looks like a 9, that's an a, and a 0 is equal to 5. So that is going to be, well, I can get rid of these 3's, make it a 15 on the other side. The 0 isn't going to be doing anything. So 2a to the 3 over 2 plus a cubed is equal to 15. I suppose we could solve that. Any of these answers looking, it's going to be one of these, it's not going to be A or B, it's going to be one of these 2/3 powers. So I suppose we could just try out and see what works. I'm saying it's going to be 2/3 because it's going to cancel with these 3's that we've got kicking around here, and the 2 will cancel with that too. So we'll just be dropping it in and saying, well, actually, this one does work, doesn't it? See? Because we'd be getting 6 plus 9 is 15, so that's going to be the answer. Or we could solve it with a substitution. I suppose we could say y is equal to, well, we'd want to say a to 3 over 2, and then say we've got y squared plus 2y minus 15 is equal to 0, so y plus 5, y minus 3, so there's our 3 solution. Kicking around there, so we've got a to the 3 over 2 is equal to 3, and then lo and behold we're off to C again, but they gave us some fairly friendly numbers to try out. C. Tangents to y equals e to the x are drawn at those 2 points. These tangents cross the x-axis at A and B respectively. It follows that for all P and Q, what is the relationship between those? I suppose we look at the gradient. They've given us 2 points on a straight line. For each straight line we've got the tangent point and the intersection of the x-axis, so let's go with that then. So we want our change in y over change in x, so that's going to be giving us, for the p one, then we're going to have that the gradient will be e to the power p, because that's what you get on an exponential graph. Our gradient is just that same function. So the change in y, well, it's going back to y is 0, so let's say we've got 0 minus e to the power p, and then the change in x, it's cutting at a, so a minus p, and then we're going to get e to the power q will be 0 minus e to the power q. It's just going to be the same thing, b minus q there. So we can get rid of that and that to make these both 1s. And, well, minus 1 there. Get rid of that and get rid of that. So we're going to have that a minus p is equal to b minus q. Is that one of our options? A minus p is b minus q. Oh, yeah, it's just written backwards. It's C. Oh, we could see it. There's no way it could be b and d anyway, because these are exactly the same. We've got another symmetry argument here. It doesn't matter which one we're doing. They haven't said anything different about p or q. They're just 2 points with 2 lines, so we're not going to end up with an inequality. So we could have ruled those out straight away, but we still would have had to work out what was going on and ended up getting a backwards version of C, just multiplying it all by -1. So that's good. D, the area of the region bounded by the curve y equals e to the x and the curve y equals 1 minus e to the x, and the x-axis is equal to what? And then they're just telling us what ln means. Right, let's have a look at these graphs then. So we've got y equals e to the x, 1 minus e to the x. So we are going to have a bit of negative kicking around here. E to the x, so we've got that thing going on. That's going through 1. And we've got 1 minus e to the x. So we're flipping it and moving it up. So it's going to be going like that. And we want what bit? We want the region bounded by those curves and the y-axis. So we want this bit here. So where are these intersecting? They're intersecting where we got 1 minus e to the x is equal to e to the x. So that's going to be, x is going to be log half, so minus log 2. Minus log 2. So we want to do our integral from minus log 2 to 0 of, we're taking the 1 minus off of the other one. So e to the x dx minus the integral from minus log 2 to 0, 1 minus e to the x dx. So, well, these things aren't changing much. So that's going to be 1, and then what we're going to have minus a half for that first integral. The second one I think I might actually want to write out. Actually, I don't think I really do I? Let's put it in brackets though, because we're taking it off. I don't want to make a mess up on this. So we're going to have an x. So that will be 0 first time around. Then we've got a minus e to the x, so that'll be then a minus 1 in there. Then next time round, we're going to be taking off a minus log 2 for a plus log 2. And then we're going to be taking off a minus a half for a plus a half. So you might want to put that on an extra line. I'm just trying to save a bit of screen space. So we've got a half here, and we've got minus a half there, and a plus log 2. So we're going to have 1 minus log 2, which is B. Right, fairly standard calculus question. 6 vectors, v1, v2, all the way up to v6, are chosen to be either that or that with equal probability, each choice made independently. The probability that the sum of all the vectors is 10/8 is what? So if we want to get to 10/8, we've got to add up all 6 of them. We're going to have, what, 4 of these? 2 of those. So how many ways can we pick 2 things out of 6? That's going to be our, well, let's get it on the old triangle. 1, 4, 6, 4, 1, 5, 1, 6, 10. We're going to want that one. So that's 15. And how many are we going to, I'm going to need the whole row, see how many we've actually got in total. So 20, 15, 6, 1, 50, 64, 15 out of 64. C. Pretty standard one, that one as well. Okay, F, the tangent to the curve y equals x cubed minus 3x at that point also passes through the point 2, 0 for how many values of a? Right, well, let's get that tangent then, because we've got 2 points and we can get the gradient, so we can get that straight line, I suppose, and we know what the gradient should be. Is it actually going to match? I suppose that's what we're getting at, isn't it? If we create a straight line, yeah, that's going to work, isn't it? So let's go y dash 3x squared minus 3. That's the gradient. Well, the gradient at that point is going to be 3a squared minus 3. So we have to see now whether that would go through the point 2, 0 by looking at that gradient as well. So the gradient of the line between these 2 points needs to match the gradient as the tangent of the curve. Yeah, so that's the tangent gradient. That's what I'm trying to articulate on this. This is our tangent gradient. And the gradient between 2 points is going to be change in y, which is a cubed minus 3a, well, minus 0, over change in x, a minus 2. So these things need to be equal to each other. We need to have the same gradient on both of them. So 3a squared minus 3. A cubed minus 3a is 3a cubed minus 6a squared minus 3a plus 6. Okay, the 3a's cancel, and we've got 2a cubed. Actually, I can divide everything by 2 then, can't I? So I can get rid of that. Minus 3a squared plus 3 is equal to 0. Is that an easy? Doesn't look like an easy cubic. I can't see an instant answer on that. So let's have a look at it then and see where the turning points are, because that'll tell us how many roots we've got on this. So 3a squared minus 6a is equal to 0. So we've got a is 0, or we've got a is 2. Yeah, a is 2. So that's our two turning points. So what are the values on these then? So that would give us 3. I'm just putting the a values back into there to see what the y coordinates would be. So our y coordinates would be 3 there. We'd have 8 plus 3 is 11 minus 12. So we've got minus 1. So we have got above and below the line. So we are getting that set up. So we're going to have 3 roots on this. So it must be D. There's going to be 3 solutions to that equation just by looking at where those turning points are. We've got one above the line, one below the line. So we must have 3 roots. Okay, that's quite a nice question. Onwards to G. The sum of this, sine squared 1 degree, sine squared 2 degrees, good lord, all up to sine squared 90 degrees is equal to what? Right, that's not very pleasant, is it? How are we gonna compare this to something? Right, okay, it's ended up somewhere around the middle, around about half of all of this. So suggesting comparing this to cos might be a good idea. I mean, if we changed all of those to 1 minus cos squared 1 degrees, and then plus 1 minus cos squared 2 degrees, so that would be this sum. We don't have 0 in, which is interesting, because this is going to be starting. That doesn't get all the way up to 1 because you haven't got the cos 0 in. It doesn't matter with sine. Actually, I mean, we could put in sine squared 0 degrees. That'd be fine, wouldn't it? If we added it in, because it's not adding anything to the actual sum. So if we put that in as well, then we've got, yeah. Well, okay, so let's call that S for our sum. And then that would be, these would have to be the same, wouldn't they? Wouldn't they? Yeah, because if we've got sine going from there to there, only going up to 90 degrees, we've got cos going from there to there. They're just opposites of each other. So they would be exactly the same. So that sum then, and then we've got this one. We're adding up. How many are we adding up here? We're going from 0 up to 90. So we've got 91 ones minus the same sum. And that's got to be the same thing. I think I'm saying these things are the same. Yeah, so this sequence, if I just write that they've given us just in sines, must be exactly the same if we replaced it with coses, because of how the graphs look. You know, sine is just cos shifted off to the side. So we're going to get exactly the same sum. And it's also going to be equal to this, because that's our identity between sine squared and cos squared. Yeah, so these things are going to be the same. We're saying that 91 minus s is equal to s. So s is going to be 91 over 2, which is 45.5. D. Okay, that was a very nice question. Yeah, something to think about. H. Which of the following graphs shows that? Right, it just about hangs on the top of the screen. In that range. Well, let's do the classic. Oh, actually, they're all starting in the same way. I was going to say, let's do the classic x equals 0 on there, but I'm not really sure that's going to help, is it? Because they're all starting on the same sort of positive value. Right, what else? In terms of these peaks, we seem to, I'm guessing it's not going to be E, but that's just because they've got A and B look much the same and C and D look much the same. So let's see where this peak would be then. What are we getting? We want to make the bracket as large as possible. So we're going to want this thing to be 0 and this thing to be -1 if we can do both, which we can, because we can do that at 3 pi over 2. So that's going to be the only maximum. We're just going to get one maximum in that transition from third to fourth quadrant. So that fits with A and B, doesn't fit with C or D, well, or E, because he's got 2 maxima there. So that's limited it down to those. So question is, how many roots have we got then? Have we got 3 roots, or do we go negative? Which is going to be the best one to go for on this? I mean, I suppose I could solve this. I could turn that into a quadratic in sine. But surely we can find something if it goes negative or not. Are we going to be able to get that bracket to go between 0 and 1 in this range? I mean, what if we had pi over 2 in here? If we would do, well, they're talking degrees. If we had 90 degrees, we'd have 9, and then we'd be taking off 8. So that leaves us with 1, but then that would be 0. So that gives us a root anyway. So we've got one of the roots. So if we go beyond that, we're thinking that's probably going to be either here or here. If we go beyond this, then are we going negative? So if we were going up to, say, well, 3/4 of pi, we'd have 9 minus 8 root 2 over 2 minus, well, 6 over 2, so -3. So we'd have 6 minus 4 root 2. Root 2 about 1.4, so that is definitely between 0 and 1. So we are going negative, so it's going to be A. It just saves having to work this out. Yeah, we could do the old cos squared is 1 minus sine squared, but then you've got to work out, actually solve that quadratic and see quadratic, see how many roots you've got. And yeah, it's just a bit quicker doing it that way, I think. Yeah, it's a tough graph one, I think. Right, the sequence is defined by A0 equals 2, and then for n is greater than equal to 1, an is 1 more than the product of all previous terms. A1 is 3, so that's 2 plus 1, A2 is 7, 2 times 3, then plus 1. So what is the relationship between, well, either an and an minus 1 or an and n? Was it none of those? So what are we doing then? We're going 2, then we're doing 2 plus 1. That gives us, so 2 is 2, 2 plus 1, oops, that's a lot of lines, is 3. Then we do 2 times 3 plus 1 is 7. And then we'll be doing 2 times 3 times 7 plus 1. Okay, and then we're just going up like that. So that's 43. So what's the pattern? We've only got an minus 1s in there. So what are we doing on this? What's the relationship to the previous one? So if we're doing, that's an minus 1, obviously, that we've got there. And we've got a plus 1. And then that is equal to an. So what is this bit? That's our an minus 1. So we've got a 2 compared to a 3. We've got a 6 compared to the 7. So that's an minus 1 minus 1. Yeah, it's just what we had before we added the 1 onto it. Is that any of the... Oh, wow, that is B. Right, that was a very quick question I. 4 distinct real numbers A, B, C, and D are used to define 4 points. Okay, so they've got similarities in their coordinate sense. We've got AB, BC, CD, and DA. Quadrilateral ABCD has all 4 sides the same length. If we've got what relationship? Right, well, there's going to be a lot of Pythagoras on this then. So I'm assuming, what have they told? Right, so we've got distinct real numbers, and they have put A, B, C, D. So I am assuming then that we are going A, B, C, D, going around our quadrilateral, and they haven't put A and B diagonally opposite each other, because that would be unfair. I mean, no one writes quadrilaterals like that, so I think we can go with that. So that will mean then, if we're going around looking at each side, we're going to have that B minus A squared plus c minus b squared. So I'm just doing Pythagoras on each pair. So that's going A to B. That will be equal to B to C. So that would be c minus b squared plus d minus c squared. And that will also be equal to d minus c squared plus a minus d squared, which is also going to be equal to d minus a squared plus a minus b squared. Right, and of course we can flip around these minus signs however we want. So what have we got? Actually, we've got a lot of things cancelling here. So we've got b minus a squared is equal to d minus c squared. That's come from that line. And then we've got, well, these are then the same. So we've got c minus b squared is equal to, which one's this? A minus d squared. The hardest part of this is just reading all the different combinations. These ones are the same, aren't they? So we've got d minus c squared is, oh, that's just repeating what I've said on the first one. Yeah, if we cancel that one and that one on this bottom line, I'm getting the same as what I had at the top. These are only two combos then. I think it is, isn't it? There are only two combos. I'll get another repeat of the second one. Right, so we've got these two things having to be the same. And right, they're looking similar to A, B, and C on these. But yeah, it says if and only if on these, and they're not if or only if because we've got both of them. So it feels as though, what's going on with D? D's all manner of weird. D is all manner of weird. How am I going to unpick that? Which ones are these exactly the same as? So I've got A, that is A, this one here. The C minus B one and the A minus D one, so that's C, which is that one. This one doesn't seem to appear in it at all because A and C don't come into contact for, yeah, so it's not going to be this, it's not going to be B. A and C look as though they're ruling each other out because we can get both of them. So how am I going to get anything to do with D? What is D even telling me? So they're A minus B, which is this bracket, C minus D is that bracket. So if they, that looks a bit like difference of two squares if we've taken it apart. So, okay, let's try taking it apart then. So if we've got B, well, they've done it the other way around. So let's go A minus B squared minus C minus D squared is equal to 0, difference of two squares. So A minus B plus C minus D, A minus B minus C plus D is equal to 0. Okay. And we could do the same thing for the other one. Do we care about the other one? Well, let's put them in order again. So B minus C, then plus A minus D, and then B minus C minus A plus D is equal to 0. Are any of these things, well, what's going on with all of this then? These ones are, how is this even helping? How is this helping? Are any of these brackets the same? I mean, I'm just seeing if between the two lines we've got the same thing turning up. So here we've got A and C are the same sign, B and D are different signs. So this bracket, the first bracket and the last bracket are the same, aren't they? Because this one here, we've got A and C the same sign. Here we've got, so the second bracket, we've got B and C are the same. Yeah, so we've got duplicates then. These, we got three different brackets there. So I could rewrite this bottom one here as being A minus B plus C minus D, doing the last bracket, taking a minus 1 out of here. B minus C plus A minus D. And then this one, we've got the same thing, A minus B plus C minus D. And this is the thing they got in the answer. So I'm wondering if there's going to be something in this then. That's the one they've got, that duplicate bracket. Because if that was 0, then it does give us our answer. But it's saying if and only if. It's not just saying if. If it just said if, we're fine. If it was just if that, then great, we've got our 0. But only if. So they're ruling out these other brackets from being 0. So A minus B minus C plus D. So what if that was 0? If that was 0, then what is that telling us? Right, so they're saying that can't equal 0. Well, actually, if this wasn't equal to 0, is what they'd be saying. So we'd have to have both of those others being 0. Yeah, we'd have to have both that is 0 and B minus C plus A minus D is equal to 0. Because that's the only way we're going to get both of those things equal to 0 if the other one isn't. So that would fit with the if and only if. So if we have both of those, what does that mean then? What does that mean? I mean, if we added them together, we'd get 2A minus 2C is 0. So A is equal to C, and they can't be equal to each other because they're distinct. Right, okay, that was, yeah, that was tricky. That was, yeah, really having to be guided by the answers. It's coming out as D, but that was by no means obvious. If they didn't have that answer written there, I don't think I would have got to the end of that. It was only working towards it that made it possible, because of all the different ways that you can put the minus signs in, then spotting that 2 of those brackets are the same, and then the consequences if that isn't 0. Yeah, and it fits with that only if, because yeah, if we're relying on, we just say, well, okay, the second bracket here is 0, but this one isn't, the fourth one, then we're still relying on A minus B plus C minus D to be equal to 0. So we're still relying on that outcome in D. So that's why it makes it an only if. So we have to have both the second and fourth bracket 0 if the first and third one isn't. Yeah, that was a very difficult end, I would say, to those questions, because the others weren't that bad. I mean, I was straightforward. H was fiddly as a graph one goes, but it wasn't that bad. G was, I really liked G. That required a bit of lateral thinking. But then the others were all pretty straightforward. F was a standard question. E was weirdly standard question. That was very simple. D was just a straight off A-level question. The C was pretty easy. B was, a real opener question. There wasn't really much to do with B. And same with A. So they gave a bunch of easy and middling questions, and then they gave question J at the end, which was probably more difficult than all of the others put together. I mean, you might have a different opinion on which ones were the most difficult, but J was a challenging one, to say the least. But it was a nice batch, kick off the papers, got us all warmed up.